In the realm of machine learning, compute resources are the backbone that powers data processing, model training, and inference. These resources can range from local machines to powerful cloud based clusters. Understanding how to configure these resources effectively is crucial for optimizing performance, cost, and scalability. This presentation will delve into the specifics of configuring attached compute resources, with a particular focus on Apache Spark pools, within the context of designing and preparing a machine learning solution. Compute resources are essential for handling the vast amounts of data and complex computations involved in machine learning. They enable parallel processing, which significantly speeds up data processing and model training. Proper configuration ensures that resources are used efficiently, reducing costs and improving performance. Inadequate or misconfigured resources can lead to slow processing times, increased costs, and even failed projects. Therefore, understanding how to configure and manage these resources is a critical skill for any data scientist or machine learning engineer. Apache Spark is an open source, distributed computing system that provides an interface for programming entire clusters with implicit data parallelism and fault tolerance. It is designed to be fast and general purpose, supporting a wide range of applications, from batch processing to machine learning. Spark's in memory computing capabilities make it particularly well suited for iterative algorithms often used in machine learning. By leveraging Spark, data scientists can process large data sets more efficiently and build more scalable machine learning models. In the context of Azure, Apache Spark pools are a key component of Azure Synapse Analytics. These pools provide a managed Spark environment that can be easily scaled up or down based on the workload. Azure Spark pools offer several advantages, including simplified cluster management, integrated security, and seamless integration with other Azure services. By using Spark pools, data scientists can focus on developing and deploying machine learning models without worrying about the underlying infrastructure. Setting up an Apache Spark pool in Azure involves several steps. First, navigate to the Azure Synapse Analytics workspace and select the Apache Spark Pools option. Click on New to create a new Spark pool. You will need to specify the pool name, node size, and the number of nodes. Additionally, you can configure auto-scaling to automatically adjust the number of nodes based on the workload. Once the configuration is complete, click Create to deploy the Spark pool. This process typically takes a few minutes. After creating a Spark pool, it's important to configure its settings to optimize performance. Key settings include the number of executor cores, executor memory, and driver memory. These settings determine how resources are allocated within the Spark pool. For example, increasing the number of executor cores can improve parallel processing, while increasing executor memory can enhance the performance of memory-intensive operations. It's also important to monitor the performance of the Spark pool and make adjustments as needed to ensure optimal performance. Once the Spark pool is set up and configured, the next step is to integrate it with your data sources. Azure Synapse Analytics provides several options for data integration, including Azure Data Lake Storage, Azure SQL Database, and Azure Blob Storage. By connecting your Spark pool to these data sources, you can easily load and process large data sets. Additionally, you can use Synapse Studio to create and manage data pipelines, enabling seamless data integration and processing workflows. With the Spark pool and data integration in place, you can start developing machine learning models. Apache Spark provides a rich set of libraries for machine learning, including MLlib for scalable machine learning algorithms. Using these libraries, you can build, train, and evaluate models directly within the Spark environment. Additionally, Spark's distributed computing capabilities enable you to train models on large datasets more efficiently. By leveraging Spark for machine learning, you can build more accurate and scalable models. Once your machine learning models are developed and trained, the next step is to deploy them. Azure Synapse Analytics provides several options for model deployment, including Azure Machine Learning and Azure Kubernetes Service. By deploying your models to these services, you can create scalable and reliable endpoints for real-time inference. Additionally, you can use Azure Synapse Studio to manage and monitor your deployed models, ensuring they perform as expected in production environments. Monitoring and optimizing your Spark pools and machine learning models is crucial for maintaining performance and cost efficiency. Azure Synapse Analytics provides several tools for monitoring, including metrics and logs. By regularly monitoring these metrics, you can identify performance bottlenecks and make necessary adjustments. Additionally, you can use auto-scaling to dynamically adjust the number of nodes in your Spark pool based on the workload, ensuring optimal resource utilization. Continuous monitoring and optimization help ensure that your machine learning solutions remain efficient and cost-effective. Security is a critical aspect of configuring and managing compute resources. Azure Synapse Analytics provides several security features to protect your data and compute resources, including network security groups, role-based access control, and encryption. By implementing these security measures, you can ensure that your data and models are protected from unauthorized access and potential threats. Additionally, it's important to regularly review and update your security settings to address any new vulnerabilities or risks. To get the most out of your Apache Spark pools, it's important to follow best practices. These include optimizing resource allocation, using auto-scaling, regularly monitoring performance, and implementing robust security measures. Additionally, it's important to stay up to date with the latest features and updates from Azure Synapse Analytics, as these can provide new capabilities and improvements. By following best practices, you can ensure that your Spark pools are efficient, secure, and scalable, enabling you to build and deploy high-quality machine learning solutions. To illustrate the concepts discussed, let's look at a real-world case study. A financial services company needed to process large volumes of transaction data to detect fraudulent activities. By setting up and configuring Apache Spark pools in Azure Synapse Analytics, they were able to efficiently process and analyze the data. They integrated their Spark pools with Azure Data Lake Storage to load the transaction data and used Spark MLlib to develop machine learning models for fraud detection. By deploying these models to Azure Machine Learning, they created a scalable and reliable solution for real-time fraud detection. Configuring attached compute resources, including Apache Spark pools, is a critical aspect of designing and preparing a machine learning solution. By understanding the importance of compute resources, setting up and configuring Spark pools, integrating data, developing and deploying models, and following best practices, you can build efficient, scalable, and secure machine learning solutions. The next steps involve applying these concepts to your own projects, continuously monitoring and optimizing your resources, and staying up to date with the latest advancements in Azure Synapse Analytics and Apache Spark.